day to all the dear students. This is chapter 19 Trigonometric Ratios part 2. So let us start with exercise 19b. Today exercise 19b. Let us start by question number 1, exercise 19b. I am reading number 1 question. Pay attention in your textbooks. Given that tan theta is equal to 5 by 12. So here tan theta value is given 5 by 12. Angle theta is an acute angle. So find sin theta and cos theta. So first of all you should remember tan theta is equal to opposite upon adjacent. This is the ratio we have learned earlier. So the opposite side is 5 and adjacent side is equal to 12. Accordingly, comparing, you get this. Now, but in sine and cos ratio, we need hypotenuse also. So, by using Pythagoras theorem, I write here, see, in a right angle triangle, if this is the right angle triangle, this is theta, then this is opposite side, this is adjacent side, and this is hypotenuse. So you should understand that using Pythagoras theorem, hypotenuse square, this side square is equal to opposite side square plus adjacent side square. So this way you will use our Pythagoras theorem. So here opposite side is 5 square and adjacent side is 12 square. So here 25 plus 144. So by taking addition we get 169 and taking square root on both the sides, I get hypotenuse is equal to 13 square root of 169. So likewise I get here value accordingly. Now we write our sine ratio, sine theta. Now sine theta, yesterday in the last video explained to you, opposite upon hypotenuse. So which is the opposite side here? Opposite is 5 and hypotenuse is found 13. So first ratio here sine theta. Now let us write cos theta. For that the ratio is cos theta is equal to adjacent upon hypotenuse. So writing adjacent side as 12 and hypotenuse is 30. So this way we get our two answers. Sin theta is equal to 5 by 13 and cos theta is equal to 12 by 13. So here we have completed question 1. Question number 2, exercise 19b. Here if sin theta is equal to 3 by 5, we are given sin theta value as 3 upon 5. Theta is an acute angle. So find cos and tan theta. So no problem. We all know sin theta is opposite upon hypotenuse. Now opposite upon hypotenuse known. So which side is unknown to us? That is adjacent side. But for our cos and tan theta we need adjacent side. So using by Pythagoras theorem again, I will find adjacent side. So hypotenuse square is equal to opposite side square plus adjacent side square. Now I want to find adjacent side, so I will make it as a subject here. So adjacent side square is equal to hypotenuse square minus opposite side square. So like this I get values. Now what is hypotenuse value here? 5. So I write 5 square minus opposite is 3 square. That is 25 minus 9. Now 25 minus 9 is 16. So we get our adjacent side here by taking square root on both the sides. So I write adjacent side is equal to 4 by taking square root here and here also. Now we have to write cos theta. First value is cos theta. Cos theta means ka word you have to remember. Ka means adjacent upon hypotenuse. So I write here adjacent upon hypotenuse. Adjacent side just now found 4 and hypotenuse is already there as 5. Second is tan theta. tan theta is equal to opposite upon adjacent. So we write opposite already there 3 and adjacent is found as 4. So this way we get both the values cos theta and tan theta. Every time we'll use Pythagoras theorem to get our third side. Question number 3, exercise 19b. Triangle ABC is right angle at A. Means like this, right angle triangle. So here A, B and C we can write because right angle at A. Also find tan, sine and cos of angles B and C in each of the following cases. I'll take number 2 here. Number 1, same way you can find out by yourself. Here AB is equal to 12 centimeter and AC is equal to 9 centimeter. So I am writing AB 12 and AC 9. So which side? BC is the hypotenuse here, which is unknown to us. So we will find first BC square is equal to AC square plus AB square by Pythagoras theorem. So I write here AC means 9 square and AB means 12 square. So here 81 plus 144, that will be 225. So BC value by taking square root we get 15 here. Now we have to write ratio of sine, cos and tan of B and C, both angles. Means this angle. First I write angle B. So I write sine B is equal to, so according to this B I am writing here 15 also. So according to angle B, which is our opposite upon hypotenuse. So opposite to it is AC and hypotenuse is BC. So AC 9 and hypotenuse BC is 15. Similarly I write cos B. So cos B is adjacent upon hypotenuse. So AB upon BC. So that is why 12 upon 15. This way we get. Now the third ratio is tan B. So I write tan B. TOA. TOA word means opposite upon adjacent. So we write here tan B. So tan B is equal to, opposite to B is AC and adjacent to it AB. So 9 by 12. You can reduce it further by taking cancellation like this. 4 3s are 5 3s are. So 4 by 5 and this is 3 and 4. So 3 by 4. This way we get all the three ratios here of angle B. Now we can write all the three ratios of angle C. Sine C. So they asked to write both. So I am writing here sine C according to angle C now. So this is our figure. You see figure. In this I will take now angle C. So according to angle C, sine means opposite. So opposite side is AB and hypotenuse means BC. So AB upon BC 12 upon 15. Then cos C. So cos C, according to it, adjacent to it is AC and hypotenuse BC. AC 9 and hypotenuse 15. And the third one is tan C. So tan C means opposite AB upon adjacent AC. So that is 12 by 9. So now by cancellation you can get all the three ratios here likewise. Now here I cancel 4 3s are 5 3s are. So I get 4 by 5. This is 3s are 5. 3 by 5. 4 by 3. Likewise you can write all the three ratios accordingly. Question number 4, exercise 19b. Triangle PQR is right angle at R. So this is right angle triangle. This is PQR, right angle at R. Find tan, sine and cos of angle P and Q in each of the following case. So I will take third number question, first and second, same way you can do by yourself. PQ is equal to 3.7. So I write PQ, this is 3.7. Then PR PR is equal to 3.5 centimeters. So I write PR 3.5 centimeters. Now third side is not known to us, so we can find it by using Pythagoras theorem. So writing Pythagoras theorem, we can write PQ square is equal to PR square plus QR square. This is 3.5. So this is PQ means 3.7 square, PR means 3.5 square plus QR square. So now we can take this 3.5 square here on this side. So I get QR square is equal to 3.7 minus 3.5 square. Now you can use your factorization method, a square minus b square type. So a minus b in the bracket, a plus b in the bracket. So accordingly I'll get here 0.2 by subtraction and here 7.2. So we get here this way 1.44. Now we already know that 144 is the square of 12. So I write here QR value by taking square root. On both the side 1.2 centimeter. So we get here third side also. Now let us write our sine, cos, tan of P and Q both. So first I write sine P angle. Angle P you can write here. So according to this angle which I put here dot, you can see sine means opposite upon hypotenuse. So according to P angle, QR side is opposite to it and hypotenuse is PQ. So that is 1.2 upon 3.7. That we can remove the decimal point upside down and write 12 by 37. Then I write cos angle P. So cos is adjacent PR upon hypotenuse PQ. So that is 3.5 upon 3.7. It means 35 by 37 by removing decimal point. And the third is tan P. So I write here tan ratio, tan angle P. So tan means 2R. You all know opposite upon adjacent. So here I write opposite to P, QR and adjacent to it PR. So QR found as 1.2 and PR is 3.5. So we get 12 by 35. These are all the three ratios of angle P. Now let us write of angle Q here. Again the same three ratios sine, cos and tan, but for angle Q. So I write sine angle Q is equal to. So for that in a figure we have to check angle Q. So sine means opposite upon hypotenuse. So opposite to angle Q is PR and hypotenuse PQ. So 3.5 upon 3.7, 35 by 37. Then cos angle Q. Now cos angle Q. So cos angle Q means adjacent QR upon PQ. QR is 1.2, PQ is 3.7, 12 by 37. And the third is tan angle Q. That is tan means opposite upon adjacent. So that is 3.5 by 1.2, 35 by 12. So this way I have written all the three ratios for angle Q also. You can see. So here we have completed our question number 4, part number 3. So accordingly you also can do number 1 and 2 in the same method. Question number 5 of 19B. Question is, for any angle theta, state the value of sin square theta plus cos square theta. So here first of all I write sin theta ratio is opposite upon hypotenuse. Then cos theta is adjacent upon hypotenuse. This is the values we have Now we write square of them, means we will take value. So sin square theta plus cos square theta. This value is needed to us. So how we solve it, you see. Now I take square of this, opposite upon hypotenuse whole square, plus cos means adjacent upon hypotenuse whole square, this way. So now opposite square upon hypotenuse square plus, next is adjacent square upon hypotenuse square. So here adjacent square upon hypotenuse square. Now adding, as the denominators are same, we can add the numerators here like this. Denominator is hypotenuse square as it is. So here what is opposite square plus adjacent square? In any right angle triangle, one is opposite side and one is adjacent side. So sum of them is also hypotenuse square only. So I write hypotenuse square upon hypotenuse square. So that will cancel 1 here. So what is the value of sin square theta plus cos square theta? Anytime, whenever sin square plus cos square, value will be 1. Always you have to remember this. This is very important result for 9th and 10th standard, in which for any angle theta, which theta is acute angle. So for that value sin square theta plus cos square theta is 1. Question 6, exercise 19b. Here the diagonals ACPD of rhombus ABCD meet at O. If AC is equal to 6, BD is equal to 8, find sine OCD. So students, I am drawing figure first of all. This is the rhombus ABCD, and these are the two diagonals. Okay, and they meet at O. It is given in the question. And also that AC is 6. So I would like to write as 3, 3, because we know that diagonals bisect each other, and BD is 8. So I would like to write 4, 4. Again the same reason, that diagonal bisect. Now we want to find sine OCD, means this angle of sine. So for that we know that diagonal bisect each other at 90 degree. So OCD means this angle, and this is 90 degree. So in triangle OCD, we write by Pythagoras theorem. I would like to find CD value. So here I write CD square is equal to OC square plus OD square. Now OC value is 3 and OD value is 4. So likewise substituting values here. 3 square 9 plus 16 is equal to 25. So this way we can find out our CD value. So CD, now taking square root, is 5 centimeter. So now this value also we know. One more thing, that in rhombus all the sides are always equal. Now we take OCD, sine OCD, that is C angle we have to take care. So opposite to C is OD and hypotenuse is CD. So OD value is 4 and CD is 5. So this is our answer of sine OCD. So question number 6, we have to use our previous knowledge of rhombus and how they bisect, the diagonals bisect each other. Question number 7 of exercise 19b. If cos theta is equal to 0.6. So here cos theta is equal to 0.6. Find the value of 5 sin theta minus 3 tan theta. Means we need to find value of sine and tan, both the ratios. So first of all, I convert 0.6 as 6 by 10 and then reduce it by taking its simplest form 3 by 5. Now we have to find sine theta and tan theta. This is adjacent upon hypotenuse. The ratio, cos ratio we know well. Now we want to find opposite side. So by Pythagoras theorem, I write here that hypotenuse square is equal to opposite side square plus adjacent side square. So now using this, I put value here. 5 square is equal to opposite side we don't know, we want to find out, and this is 3 square. Therefore opposite side square is equal to 5 square minus 3 square. It is 25 minus 9. So 25 minus 9, that will be 16. So here we write 16 and taking square root, opposite side is equal to 4. So this is the value of opposite side we found. Now we have to write sine and tan ratio. So I like to write here sine theta. Sine theta, we all know what is the ratio. Sine means opposite upon at hypotenuse. So opposite side upon hypotenuse is equal to 4 upon 5. Now we write tan theta. Tan theta is equal to opposite upon adjacent. So what is your opposite side? Again 4 and adjacent side is 3. So this way we found sine and tan theta values also. So now let us take our find the value, means what we want to find out here, that is 5 sine theta minus 3 tan theta. So we'll calculate this by substituting values here. So now 5 as it is, sine theta value is 4 by 5 minus 3 as it is, and tan theta is 4 by 3. So this 5 and 3 get cancelled, 4 minus 4. So that value will be 0. So here we get our answer number 7 by calculation. You can see first of all we have to use Pythagoras theorem to get our unknown side, that is opposite side, and we get our final solution accordingly. Question number 8. In a right angle triangle, it is given that A is an acute angle and that tan A is equal to 3 by 4. So tan A is equal to 3 by 4. This value is given to us. Without using tables, find the value of cos A. So here we want to find cos A value. So this is very simple. You all know tan ratio means opposite upon adjacent. So we don't know hypotenuse here. So using Pythagoras theorem, we'll find the hypotenuse. So using by Pythagoras theorem, we write here, according to Pythagoras theorem, hypotenuse square is equal to opposite side square plus adjacent side square. So this is 3 square plus 4 square. 9 plus 16 is equal to 25, and taking square root on both the sides we get hypotenuse is equal to 5. Now we will write cos A value. They asked to write cos A value. So cos A means which ratio? It is adjacent upon hypotenuse. So I write here adjacent side upon hypotenuse is equal to, adjacent side is 4 and hypotenuse is 5. So we get answer as 4 upon 5. So this is question number 8. Now question number 9 is also same as question number 7 and 8 only. So sine value is given to you. You can find cos and tan value by yourself and add it. So I am leaving question number 9 up to you. Question number 10, true false, you can solve by yourself in your textbook only. Okay, and now question number 11 we will see right now. Question number 11 is using the measurements given in the figure. Figure is 19.15. Find the value of sine phi. See here the symbol is phi and tan theta. Write an expression for AD in terms of theta. So first of all, let me draw the figure here. These are two triangles, two different triangles. It is drawn here like this. It is A, B, C, D. Values are written 13, 14. Here is theta. This is phi. Also it is given 90 degree and this is also 90 degree, 5 and 12. So this way figure is given. Also I can join this horizontal line here. So that what we can say, this 12, so here I would like to give A, B, C, D, E suppose. So this BC and ED are same, so I would like to write here 12. EB and CD are same, so here will be 5. But this whole side is 14, so AE will be 9. So likewise we can rearrange the values here. Now after this figure, let us start with our question 1, that is find the value of sine phi. So here phi angle is in this BDC or BCD triangle, you can see underneath of it. So using that triangle, I will take sine ratio. So sine phi is equal to opposite to it CD and hypotenuse is BD. So that here CD value is 5 and BD is 13. So this way we get first answer A, sine phi. This is our A answer. Now B answer, that is tan theta. So tan theta means theta is here located, that is opposite upon adjacent. It means ED upon AE. See the figure everybody, opposite to theta there is ED side. So that you should understand. ED is 12 and AE is 9. By cancellation, we'll get 4 by 3 as our tan theta value. Now, second, write an expression for AD in terms of theta. So, this is our AD which we have to write in terms of theta. That is our second value. So, let us write it. How? So, you all know that first of all this AED triangle, opposite side and adjacent side known to us. So, we have to write AD value. So, I write here AE is equal to 9, ED is equal to 12 and AD square is equal to AE square plus ED square. But first of all, we write cos theta also from it. So cos theta is what? Adjacent AE upon AD. So I write AD is equal to AE upon cos theta like this. So we want to write AD in terms of cos or sine. So likewise we'll get here, but AE value is 9. So I write 9 by cos theta. So this is the first value of AD we found. In another way, I would like to write sine theta value. Sine theta is opposite, that means ED upon hypotenuse AD. So using this, I will write here AD is equal to ED upon sine theta. Now what is ED value here? 12. 12 upon sine theta. So we have written another way of AD also. So this way, two way you can write AD value, either sine or either cos theta. So these are the answers of our question number 11. Question number 12. ABC is a right angle triangle, right angle at B. Here the figure is given, so I am drawing a right angle triangle, that is ABC. right angle at B. This is right angle. Then this is 2 given, this is 1 given, and here is angle theta drawn. So this is our figure number of question 12. Here angle ACB theta, AB is 2 units, BC 1 unit. Find the value of sine square plus tan square theta. So here we have to find two values, sine theta and tan theta. For that, first of all, I need AC value. So I take Pythagoras theorem. By Pythagoras theorem, I would like to find first hypotenuse. So for that, AC square is equal to AB square plus BC square. So here 2 square plus 1 square, 4 plus 1, that is 5. So here I get, by taking square root, AC value root 5 units. Okay, now we will write our sine and tan ratios using these values. So again, sine ratio, sine means opposite upon hypotenuse. So here theta's opposite side is AB and hypotenuse is AC. So AB is 2 and AC is root 5. This is our value of sine theta. Now let us take tan theta value. Tan theta is what? Opposite, that is AB, upon adjacent, that is BC. It means 2 by 1 here. So we have written here both the values, sine and tan theta. Now we'll find the value accordingly. We need here sine square theta plus tan square theta value. So you can find any value like this, students. So here I write sine square theta. So 2 by root 5 whole square. Square is there. So we have to put square, and this 2 by 1 is 2 only, is square. So now taking square of both the sine and tan theta. So here I get 2 square 4, root 5 square 5. 2 square 4, 1 square 1. By taking LCM, this is 5, taken LCM, and here is 1. So 4 plus 5 4s are 20 by 5. This is 24 by 5. Now 24 by 5 you can convert into mixed fraction also if it is required. So in the answer you are given 4 integer 4 by 5, that is same as 24 by 5. So here we have completed question number 12 answer, students. First of all, using Pythagoras theorem find hypotenuse, and then using sine and tan value you get required answer. Question number 13, there are two parts, first and second. So both have same method, kind of same method. I take second part here. If cos theta is equal to 12 by 13, here value of cos theta is given to us. Cos theta is equal to 12 by 13. Now find the value of sin theta and tan theta, and then find the value of 2 sin theta minus 4 tan theta. So now this is our ratio adjacent upon hypotenuse, like this. So now using our Pythagoras theorem, we can write here hypotenuse square is equal to opposite side square plus adjacent side square. So here we can find out opposite side by calculation. This is 13 hypotenuse and 12 is adjacent side. So here I write 13 square is equal to opposite square plus this is 12 square. So we can write in next step opposite side square I am taking as a subject. So 13 square minus 12 square. This is 169 minus 144, that is 25. So my value of opposite side is equal to 5 by taking square root on both the sides. Now we can find sin theta and tan theta values. So sin theta I am writing here, it is opposite upon hypotenuse. Now you should remember, now all the students, that sine means so. So means SOH. That is opposite upon hypotenuse. So likewise you can write your sine and tan ratio. Opposite is 5 and hypotenuse is 13. Similarly I write tan theta value opposite upon adjacent. So opposite value is 5 and adjacent is 12. Now we will find the required value here, which is given as 2 sine theta minus 4 tan theta, like this. Substitute here values accordingly. Sine theta we have found right now 5 divided by 13 and tan theta is 5 by 12. So this you can cut 4 3s are 12. And here 5 2s are 10 by 13 minus 5 by 3. Taking LCM, we will solve this. So 10 3s are 30 minus 13 5s are 65 upon 39. Here 65 minus 30, we get minus 35 upon 39. So this is what we get our find the value answer, and sine and tan theta ratios already written 5 by 13 and 5 by 12. Now students, question number 14, 15, 16, 17 all are same kind. So I will not do 14, 15, I will do 16 onwards, that they are quite difficult for you. So I am solving question number 16. Here if B tan theta is equal to A. So we can write tan theta value as A and this B in the denominator as A by B. Now we have to find the value of cos theta plus sin theta upon cos minus sin theta. For that we use our tan ratio. We know tan means opposite upon adjacent. So now we first find hypotenuse using Pythagoras theorem. So I directly write that Pythagoras theorem, this is a square plus b square. So here there is no calculation, so we write direct square root on both the side. So that will be under root a square plus b square. This a square plus b square, we cannot write separate a plus b. We have to write in the square root sign. So this is our hypotenuse we found. Now we write sine theta value first. Sine theta means opposite upon hypotenuse. So opposite means a value upon hypotenuse is square root a square plus b square. Now we write cos theta value. So cos theta is equal to, ratio is adjacent upon hypotenuse. So adjacent means b upon square root a square plus b square. Now let us find the value given. So here I write cos theta plus sin theta upon cos theta minus sin theta. This is the value we want to find out. So I will substitute the values of cos and sin in this. For that, cos value I substitute here as b upon square root a square plus b square, plus sign in between. Sin theta is a upon square root a square plus b square. In whole denominator, cos theta minus sin theta, that I will write here as cos theta is b upon square root a square plus b square minus a upon square root a square plus b square, sin theta value. Now we'll solve further. See here, denominators are same in numerator also and denominator also. So I'll write accordingly as upside b plus a, or a plus b you can write square root a square plus b square, and in the denominator of it will be b minus a upon square root a square plus b square. Now we will take its reciprocal, Like here will be b plus a upon square root a square plus b square. This whole denominator we take reciprocal and write in a multiplication way. So the square root a square plus b square upon b minus a. So this will get cancelled here. So what we have left with, that is b plus a in the numerator and b minus a in the denominator. So this is our final answer, b plus a upon b minus a. Using same method, students, you can find out your 14 and 15 question answers. Now let us start question number 17. If phi tan theta is equal to 4, value phi tan theta is equal to 4. So using it, we can write tan theta is equal to 4 upon 5. Likewise, in cross it will go, so 4 upon 5. Now, we have to find value of phi sin theta minus 3 cos theta upon phi sin theta plus 2 cos theta. Means we require sin and cos both the values. So we all know that tan means opposite upon adjacent. Now we need to find hypotenuse. So I write hypotenuse square is equal to opposite plus adjacent square. So here we write 4 square plus 5 square is equal to 16 plus 25. That is 41 here. So here I get value as hypotenuse is equal to square root 41. Now let us take our find the value equation, that is 5 sin theta minus 3 cos theta upon 5 sin theta plus 2 cos theta. Before that, I write here sin theta value. Sin theta is what? Opposite upon adjacent. Opposite upon hypotenuse. So opposite is 4. Hypotenuse is square root 41. Cos theta is equal to adjacent upon hypotenuse. So these are our values of sin and cos. Now we will substitute them in our required equation here. So now sin theta is 4 by square root 41. So substituting here, minus 3 cos theta is 5 upon square root 41. Denominator 5 sin theta is 4 by square root 41 plus cos theta is 5 upon square root 41. So this way we get a solution. Now we simplify this. I write it here now so you can understand. Numerator first of all we see here, that is 5 4s are 20 upon square root 41 minus 5 3s are 15 upon square root 41, like this. And in the denominator it is 5 4s are 20 upon square root 41 plus 5 2s are 10 upon square root 41. Now you see numerator are different but denominators are same. So we can take direct subtraction, 20 minus 15, 5 by square root 41. In division with, this is 20 plus 10, 30 by square root 41. Now solving this accordingly by taking reciprocal. So here I take 5 by square root 41 multiply square root 41 by 30. So this 2 cancelled and 5 6 are 30 here. So I write here answer is 1 by 6. This is the final answer we found here, 1 by 6 of question number 17. So any question can be solved like this, students, using our sin and cos ratios. Question number 18. If 13 sin A is equal to 5. 13 sin A is equal to 5. This is given to us in the question. So we can write sine A is equal to 5 by 13 by taking this 13 on right hand side in the denominator. Now find the value of 5 sine A minus 2 cos A upon tan A. So sine A is opposite upon hypotenuse. So we require to find first of all which is the required unknown side adjacent square. So I write by Pythagoras theorem, here hypotenuse square is equal to opposite side square plus adjacent side square. And substituting values here, 13 square is equal to 5 square plus adjacent side square. Therefore, adjacent side square is equal to 13 square is 169 and taking this on other side 5 square is 25. So here it is 144. So taking square root on both the sides, adjacent side is equal to 12. So we get our adjacent side. We can find other two ratios. They are cos and tan theta. So I write here sine A value. Sorry, sine A is we have already cos A value, that is adjacent upon hypotenuse. Adjacent is 12 and hypotenuse is 13. And the other is tan A ratio. Opposite, that is 5 and adjacent is 12. So these are three. All the ratios we have written here now. Sine, cos and tan. Now we will substitute them in the required find the value type of question here. So I write here 5 sine A minus 2 cos A in division tan A. So here 5 into sine A. Sine A value already we are given as 5 by 13 minus 2 cos A value is 12 by 13. In the denominator tan A is 5 by 12. This way substitute value 5 5s are 25 by 13 minus 12 2s are 24 by 13. In the denominator 5 by 12 as it is. Now we solve our numerator because denominators are same. So 25 minus 24 1 by 13 upon 5 by 12. Now we solve this by taking reciprocal. So 1 by 13 as it is, multiplying and taking reciprocal 12 by 5. So this is 12 by 13 5s are 65. This is our final answer, question number 18. So you can see students, this is very simple. Once you remember the ratios sine, cos and tan, you can find your answer. Question number 19, that is the last question of our exercise 19b. You can see there is equation given here, 5 cos A minus 12 sine A is equal to 0. So now we solve this equation by taking this minus 12 sign on the right hand side. So it becomes is equal to 12 sine A. How? Because you see this minus sign on right hand side go become plus, and with 0 we take anything in positive, it is positive 12 sine A. Now I write cos A upon sine A in cross like this, and similarly this 12 as it is in this denominator as 5 in a cross way. Now what is cos by sine ratio? We have seen earlier in our important result, it is cot A. Cot A is 12 by 5. So here we required find the value. So this doesn't any matter. So because we want sine plus cos. So I write what you want to find out. Sine A plus cos A upon 2 cos A minus sine A. We want to find this value. Okay, so here we substitute our value, students. They are of sine A first. Sine A value here, from here only you get 5 plus cos A value is 12. In denominator with it 2 cos A. So 2 multiply cos A is 12 minus sine A. Sine A is 5. So I write here 5. 12 plus 5, 17 upon 12 twos are 24 minus 5. So by solving it, we get 17 in the numerator and this is 19. So we get our last question answer 17 upon 19. This is question number 19, the last question here of our exercise 19b. So here we have completed our exercise 19b. I hope you understand nicely. So learn all the ratios and solve it, students, in your notebook.